The fronts of buildings in our cities are black with pollution. This is the fault of vehicle exhaust gases, gases that are as dangerous for our health as for our urban architectural elegance. That is why research is underway in this laboratory into self-cleaning, pollution-reducing cement as part of the European research project PICARDA.
The PICARDA project proved that the photocatalytic cement-based products are useful for depollution and self-cleaning. So it helps us to finish the formulation of industrial products and also to develop laboratory and on-site tests to assess the efficiency of these products.
This new cement works because nanoparticles have been added to it. This white powder is titanium dioxide, which breaks down pollution when exposed to sunlight in a mechanism called photocatalysis. Pollutants are broken down by the nanoparticles when the sun shines and then washed away by the rain. Laboratory tests have proved the mechanism works. When polluted air is passed across the new cement and exposed to UV light, the level of pollutants in the air goes down.
So we have the reduction of the pollution up to 46% after 10 minutes. Here we directly see the activation of the product and the efficiency on the pollution level.
Arnaud Placé has been carrying out tests outside. Containers covered with cement have been exposed to the exhaust gases from an electricity generator. The efficiency of the cements has been shown to vary depending on the intensity of the sunlight and the direction of the wind. Variables which are difficult to control in the real world. This pioneering use of the new cement could have a real effect on reducing pollution if other construction companies imitate it.
If we apply this product only on one building or one road, it is not enough to decrease the amount of pollution in all the city. The second point is that we don't ask our client to pay for the other citizen of the city. So it's a new approach of economic issue, and I'm sure that in sustainable development we must increase the question of who will be in charge to pay the externalities of the city.
Before public bodies are ready to pay more for this new cement, they need to be convinced that the nanoparticles it contains are not dangerous for people's health. As a result, one of the project's partners is involved in testing the safety of nanoparticles. Preliminary results show that they are harmless.
Nowadays, the proportion of active nanoparticles in cement or in concrete is currently very low. Also, once the material is exposed to the air, the particles have a tendency to clump together or to stick to particles of cement. And as a result, they are no longer nanoscale particles. Nanoscale particles can be found when surfaces are degraded, but overall, studies have tended to show that, in general, the danger of pollution is really very small.
Researchers have even proposed using such products on a very large scale for their anti-pollution properties. High levels of urban pollution could be avoided if nanoparticles were used in protective paint on the exterior of buildings or on the surfaces of major roads.